11.5 Partial Fraction Decomposition, Part 2. So far we've seen how this stuff works when the denominator can be factored into linear factors only. So let's see what happens if you don't have linear factors in the bottom. So we're looking now at non-repeated, irreducible quadratic factor. So x cubed minus 1 is a cube pattern, so that comes from x minus 1, x squared plus x plus 1. And the top is 3x minus 5. Okay, so the first part you should be familiar with. Okay, this, since it splits this way, x minus 1 could be a factor, and we have this thing as a factor. So x squared plus x plus 1, could be a denominator as well. Here, since this is linear, you would still just get an a. Over here, if that's an x squared plus x plus 1, so if it's an x squared, then you could have b times x plus c over here. Okay, now that doesn't mean that you have to have all these terms, so although a does have to be something to get this x minus 1 to show up, but b here could be 0 as long as c is then a number. So we need to go find out what a, b, and c would be. And you do that the same way initially. So we're going to multiply on both sides here by the denominator, and x cubed minus 1 is shorter, so we'll use that. So that means that on the left side, we just get 3x minus 5. And over here we get a times, so x squared plus x plus 1 is the part that we did not have yet, plus bx plus c, that's the top here, right? And we don't have the x minus 1 yet, so x minus 1. That means we have a lot of cleaning up to do, so we need to distribute here. And we basically need to roll there. And then we need to group things together that belong together. So anything with a square should come first. So it's a plus b times x squared, right? So that means I've used this one and this one. And then I need things with x's, so I have an a times an x minus a b times an x plus a c times an x. And since you have a bunch of stuff, I think it makes sense to cancel things out as you go along. And then finally we have plus a minus c. Well, that means that a plus b has to equal 0, because I don't have an x squared on the left. So I'm comparing this. I have something a plus b times an x squared, but I don't have an x squared here. So that must be 0. A minus b plus c, so a minus b plus c times x should come out then as a 3. And then a minus c needs to come out as a negative 5. Different ways you can solve it. I'm going to solve it this way. I'm going to say b is a negative a. So that when I plug that in over here, I get a minus negative a plus c is equal to 3. So a minus a negative a, that's actually 2a. So then 2a plus c is equal to 3. And here I have a minus c is equal to a negative 5. Add those. So I get 3a is equal to a negative 2. So that means that a is a negative 2 over 3. And b is the opposite of that. So b is 2 over 3. And then I have a little bit of work left to do, so I'm going to plug in my value for a into this one over here. So a negative 2/3 minus c is a negative 5. So a negative c is equal to a negative 15 over 3. So I'm going to change this to an over 3. Bring this one over here. Plus 2/3. So that means a negative c is a negative 15 divided, or plus 2, sorry. Is negative 13 over 3. So then c would be a positive 13 over 3. And then finally, you can write or rewrite that function. So that means that f of x, which is 3x minus 5 divided by x cubed minus 1, can be broken down into a over x minus 1, right? So it's a negative 2/3 divided by x minus 1, plus b, which is 2/3 times x, plus c, which is 13 over 3, and that does not have an x, divided by x squared plus x plus 1. This one would be easy to bring this 3 down, and the same thing over here because they share it, but you don't have to. So this is sort of an exception to the whole fraction into a fraction thing. Okay? Alright. So that's the third case. So the third case was when we have a non-repeated, irreducible quadratic. So hopefully you can sort of anticipate what's coming next. And that would be, we have a repeated quadratic factor. So right here is a quadratic factor, x squared plus 4. It's being repeated. You cannot reduce that. So this gives you the following breakdown. So this can come from an x squared plus 4. Well, if that's a square, and then that needs to be an ax plus b, plus an x squared plus 4 twice, and x squared plus 4 is still the factor it's being repeated, but that's the actual factor, so that could be then a cx plus d. And then the whole thing starts again. So we're going to multiply this by the original denominator, which would be the x squared plus 4 squared. And when you do that, over here you just get x cubed plus x squared. Over here we get ax plus b. X squared plus 4 cancels once, right? But that still leaves an x squared plus 4. And on this one, they actually completely cancel. This cancels completely with that. So we do end up with just cx plus d. And that makes life a little easier. Then you FOIL, so ax cubed plus 4ax plus bx squared plus 4b plus cx plus d. And then we need to collect things and order them in the right sequence so that we have the leading degrees as a cube, etc. So ax cubed, do I have any other? No, I don't. Plus, so now I'm looking for squareds. Well, there's only one, so bx squared. And again, I would cancel things out as I mark them. Now I'm looking for things with an x. So 4ax plus cx. So 4a plus c times x. And then I should just have, whoa, not that one. Now I should just have constants left. And I do, I have 4b plus d left. Okay, well this system is actually fairly straightforward, even though it looks like a bunch of junk, but a x cubed, and we have 1x cubed here, so that means a is equal to 1. B x squared, and we have 1x squared there, so b is equal to 1. We also know that 4a plus c is equal to 0, because I don't have any x's, and we know that a is 4, right? So this actually, is 1, so this actually is 4 plus c is 0, so c is a negative 4. And the last one then is 4b plus d. 4b plus d is equal to 0, because I don't have any constant. And the same thing is here, except now because of b being 1, so that means that you get 4 plus d is equal to 0. So d is also a negative 4. So that system, even though it looks pretty scary to begin with, solves pretty easily, right? I'm trying to see where I have the room. So I'm going to write it over here. Use a different color. So that means that I'm going to have to put it down over here, because I'm going to run out of room. So x cubed plus x squared divided by x squared plus 4 squared can be broken down into, let's see, ax plus b, and a is 1 and b is 1. So this is 1x plus 1 divided by x squared plus 4 plus, and then cx plus d, so that's a negative 4x plus a negative 4, so we'll make that a negative 4. And then this one would be x squared plus 4 squared. And I would leave that. You could take the negative out here, factor the negative out, as in a negative 1, and then this would be an x plus 4. And then bring this over here and rewrite that. But that just invites trouble, as in forgetting a negative here or there. So I'm just going to leave it like this and call it a day. Okay, well that's really it. So that's case 3 and case 4. So case 3 and case 4 both deal with the fact that you have a quadratic factor left. So we need to have a quadratic factor left in the bottom of the fraction. Now it does say ax squared plus bx plus c, and notice that here we only have two parts. Well, that meant in this case that b was equal to 0. So that's okay. So it does not have to be a trinomial. It just has to be a quadratic. Okay. If that's the structure, then, so if we have a quadratic that you cannot reduce any further, then you get a linear over here in the top. So then you get ax plus b in the top. And then, we just saw here a moment ago that, if you have multiple factors that are quadratic, right? So this was what? A repeated irreducible quadratic factor. X squared plus 4 is quadratic and it's repeated. So if you have that, then, you need an ax plus b over here, and you need a cx plus d over here. And that's basically it. So hopefully this made sense. Thanks.